We're going to go ahead and do some graphing, and then we're going to look at the number of zeros that show up, approximate the zeros to the nearest tenth, and approximate any relative or extreme maxima and minima. And then we're going to go ahead and graph this. So first of all, we know that because our degree is odd, and that's what we have right here, that's the highest exponent, it's going to be a disco. But we also have a positive in front, so that we know our basic shape will be like this. And so we know when we were doing quadratics, we always knew where the middle of our table was doing the negative b over 2a. Well, we're not dealing with a quadratic here, so that doesn't work. So we need to take this basic idea of what shape we need to get and use that to help us when we go to Desmos and type it in to be able to get enough points for our table. So if you've not done so, go to desmos.com, click on the graphing calculator, type this in. Remember, you can also, after you type it in, hit the little gear, and then you can hit the table feature, and then you're going to get a graph that looks like this. So I have my table on the right. So for graphing these, you can always use your table, and you can plot your points. You can see that some of these are obviously not going to fit on your graph, but I didn't know for sure, so I had my table like that. The ones that I would probably plot on my graph would probably be these right here, because the other ones are going to be, for the most part, going off your graph. So plot those points, and then you can see in Desmos you would get this. And then once again, I went ahead and I clicked where it's crossing the x-axis, so it showed me that coordinates at that point. Now, the number of zeros that we have that it's talking about is how many times you cross the x-axis. You can see you cross it only once. Now, we also need to state the approximation of the zero. Well, that would be this right here, but it says to the nearest tenth, so I'm going to go 2.7. My maximum, that's the highest point within an area, which would be this. And so that would be the 0.44, also to the nearest tenth, but those are exact numbers, so we don't have to worry about approximating it. Then we need to look at our minimum, oh, sorry, I did that backwards. That was the high point. Now we'll do the minimum. That's our lowest point. And so when we look at that, that would be this here, so that would be this. So then I can go ahead and do that. That would be about a 4.7 to the nearest tenth and about a 3.9 to the nearest tenth. And then we can also do our end behavior. Now remember, with the end behavior, it's f of x approaches and then something infinity as x approaches positive infinity. F of x approaches something infinity as x approaches negative infinity. So just as a reminder, this means as you go far to the right on your graph, well, you can see your graph goes up, so we're going to put a little positive right here. Now, this one here, we can see means as you go far to the left. As you go far to the left, you can see that you go down, so we're going to put a little negative right there. So that's our end behavior. And so really, we're going to just do that on our next problem also. So we need to do all that same information. So go to Desmos, type that in, get your table. Remember, you can get that by going to the gear, hitting the table feature, and then I'll go ahead and paste in what it should look like.